Okay, we are getting started with the warm-ups. Hopefully remember the area for a circle is pi r squared. When you are finding the sector area, you need to use x over 360. Take that central angle measure, divide it by 360, and then multiply it by pi r squared. That'll give you the sector area. When we are trying to convert 19 days to minutes, start with the 19 days. You can put it over 1. We're going to multiply it by some fraction. We know in 1 day there are 24 hours. So now my days from the top cancel with my days on the bottom. In 1 hour there are 60 minutes. So here are my hours from the top, cancel with my hours from the bottom. When I multiply these together, take 19 times 24 times 60, just divide it by 1, we get 27,360 minutes. Since we ended up with minutes there. Just a reminder of your Pythagorean theorem, a squared plus b squared equals c squared. C has to be the hypotenuse, opposite the right angle, the longest side in the right triangle. So if we know that one side is 15 yards, b is 30 yards, we're trying to figure out c. We'll take 15 squared plus 30 squared, that equals c squared. We end up with 1,125 for c squared. So taking the square root leaves us with 33.54 yards. So if we were asked to find the missing side length here, okay, we are given the hypotenuse and a side length. We're finding the other side length. I have to plug in my hypotenuse for C. Right, so we end up with b squared when I subtract 2.1 squared to equal 82.08. Taking the square root of that, it ends up to be 9.06 centimeters. Then we have our triangle area formulas. Most people say 1/2 base times height, or if it makes more sense to you to say base times height, then divide it by 2. Either is fine. So if a triangle has a base that's 48 inches and a height to the base of 3 feet, we're trying to figure out the area of the triangle. So hopefully you notice that we have feet and inches. So if I was taking 3 feet and converting it into inches, hopefully you know to multiply it by 12. So we end up with 36 inches. So if my area is 1/2 times my base times my height, my base is now 36 inches and my height is 48. When I multiply that all together, we end up with 84 inches squared. For example 4, a triangle has an area of 24 centimeters and a height of length 5. This time we have to work backwards to find the length of the base. So plug in what we know. The area is 24. Substitute that in for A. The height has length 5. We have to solve this for B. So if I take 1/2 times 5, I get 5 halves. Or 2.5. I could either divide both sides by 2.5 or multiply both sides by 2/5. We'd end up with 48 fifths for B. Or if you want to turn that into a decimal, we could say 9.6 centimeters. When we have irregular shapes that are using in circles and triangles, we wanted to Divide the shape into those circles and triangles. Then decide if you are finding area or perimeter. We know how to do that for circles and triangles. So if we're looking at this picture on the right, we have semicircles attached to the sides of a right triangle. So I'm going to call this figure 1, figure 2, and figure 3. So we're trying to find the exact distance around the circle. For figure 1, which is a semicircle, I need to take 1/2 of the circumference. Since it's a semicircle, we're only using half of its total circumference. So that means I have 1/2 times pi times the diameter, since they gave us the diameter. So 1/2 times pi times 5 leaves us with 2.5 pi. All right, so then I can look at the area of shape 2. Sorry, not the area, the perimeter. So if one side was 5, one side was 13, I need to use the Pythagorean theorem to, the hypotenuse was 13, to figure out this missing side length. So 25 plus b squared equals 169. When I subtract 25, I get 144. So when I take the square root, I end up with 12. So this part here is 12. Then for shape 3, again, I'm taking 1/2 of the circumference, 1/2 times pi times the diameter. In that circle, the diameter was 13. Oh boy, let me undo that. Your diameter was 13, so 1/2 times 13 pi would give us 6.5 pi. All right. So then we just have to find the perimeter. Part of the perimeter was 12 from the triangle. Part of the perimeter was this circumference, which was 2.5 pi. The other part of the perimeter going around this circle, semicircle, was 6.5 pi. So we really end up with 9 pi plus 12 inches when we keep it exact. For part B, we have to find the area of the shapes. So first I need to find the radius for the semicircle there. So we'll take 5 and divide it by 2. We have 2.5 for a radius. Okay, since this is 1/2 of the circle, we're going to take 1/2 times pi times r squared. So 1/2 times pi times 2.5 squared. This can all be rounded to tenths. So this would give us 9.8. For the second figure, our triangle, 1/2 base times height. The base and the height are perpendicular. We could say the base is 12, the height is 5. So that way we end up with 30. And for our third shape, again, we need to start by finding the radius. So if the whole diameter was 13, cut it in half. We have 6.5 for the radius. So when we're using half of the circle, half of the whole area, we'll plug in 6.5 for the radius and end up with 66.4. So finally, when we add up our 9.8. Take our fourth step, the whole area would be 9.8 plus the 30 plus the 66.4 to give us 105.2 inches squared. Oops, wrong one. All right, so in this example, we have to find the area between the smaller and the larger circle. So what we have to do is take the area of the big circle and subtract the smaller area, the smaller circle. So if we look at the big circle, its area equals 14. Sorry, if I give you that segment DF is 14 and segment DE is 8, we're going to take the radius, which was 14, and square it, multiply it by pi, we get 196 pi. For the radius of the smaller circle, it was 8. Take 8 squared, get 64 pi for the area. Then when you subtract those, if we keep it exact, we end up with 132 pi feet squared.